We can solve this problem without any integration. The reason is symmetry. So the region is for x between negative pi to pi, for y between negative pi to pi again. And let's look at the function. So what happens if I plug instead of x, negative x, instead of y, negative y? So the function becomes, let's simplify this expression. So here is negative x, and if we simplify this, we get 1 plus this becomes just like x squared because it's squared, but sine negative x is equal to negative sine x. That's why we have negative x squared sine y minus the same thing here, y squared sine x. And then you can see, you can easily see that it's almost the same function as our initial function, but with negative signs here and here. So which means if I just take, let me erase this. So which means if I just take this part of the problem as a function of xy, it means that fxy plus f negative x negative y, that's 0. So which means we have a symmetric region. We have negative values from negative pi to pi, negative pi to 0, and from 0 to pi. So for every pair of xy, we can put a correspondence of pair of negative x and negative y, which make it 0. So basically the integral of, which means the integral of x squared sine y plus y squared sine x over this area is 0. So that means we are left to do integral over area, the integral of 1 only. And that's a simple one, right? So it's a constant function. So we are doing that integral from negative pi to pi, from negative pi to pi again, 1 d, so let's say dx dy. So if you do with respect to dx, so that's 2 pi. And then one more time, that gives us 4 pi square. So the idea of symmetry allows us not to integrate this part of the equation because it will vanish anyways. So if you make correspondence to single integrals, this is something like this. So in one dimension, when you have a curve like this, and area under this curve here is, if this is symmetric, the area integral under this curve is 0, because this part will be positive, this part will be negative, and then they will cancel each other and make the final result 0. So that's this idea in 2 dimensions, in 3 dimensions with surfaces.